modular automation most line.
LTE covers 85% of today's industrial connectivity use cases. The LTE device ecosystem is standardized too. For extreme capacity and ultra-low latency needs, the upgrade to 5G is easy. Simply install 5G access points and they work seamlessly in your private wireless network. The local edge server can be upgraded with software.
Digital automation cloud increases productivity at our factory. We have connected AIDs to the private wireless network, and now they can run without interruptions, which wasn't the case when connected to Wi-Fi.
AIDs enable automated material feed. Our smart buffers send automated requests to the AIDs based on the sensors. We can also pull the AIDs to the production line when needed by pressing a button that is connected to the private LTE.
Hello there.
Well, hello to you.
Thanks to a fleet manager, the AIDs work in a smart swarm. They are never in each other's way, and they share the workload optimally. The AIDs can also monitor the network capacity and coverage in real time.
Digital Automation Cloud is the foundation for building digital twins of your processes. Productivity increases can be verified with a digital model prior to you making any real-world layout changes.
Digital automation enables real-time video analytics. In this case, we are tracking production material quantities. But video analytics can also be applied to production quality control. When it comes to connecting production equipment, private wireless allows better flexibility at fixed lines. This way we can easily adapt to rapid changes on the production floor.
Flexibility indeed is one of the reasons to choose wireless connectivity. You can make flexible layout changes in your assembly lines without cabling slowing you down. That brings cost reductions. A wireless network also means less configuration work when you alter the production layout.
In our factory, the layout changes pretty much every week. Like this one here, it was built up just within days and will be moved to another location after a couple of weeks.
Network slicing enables you to separate traffic from different sources or between different user groups. You can guarantee capacity for priority use and split the network resources accordingly.
Our factory wireless network has the capability to slice the network with different access point names, APNs. We plan to use this feature to separate the production environment from the development environment. We also plan to use this for personal voice or video communication. This way, we can ensure that the production network is always prioritized. Sometimes things can get lost in production. That's why we added the high accuracy indoor positioning system to give us the real-time position of our assets. Now I know exactly where the lifter is located. It should be clear by now that digital automation cloud brings us real value beyond connectivity. This value comes from the applications I quickly demonstrated, but there's so much more.
Nokia Digital Automation Cloud comes with a catalogue of applications, some from Nokia, some from existing ecosystems. You can click and deploy applications to realize your digitalization use cases and investments. The applications run locally, thanks to edge computing capability brought by Nokia Digital Automation Cloud.
That's a pause. I hope you enjoyed our tour of digital automation in Nokia Old Factory.
Thank you, Sambit and team. Yeah. Thanks.
Fiverr.
That's fine. I'm going to be here. I don't need that. So.
You can use this?
Yeah, I can use it. Can you hear me? Okay. So you all saw the video, right? Any takeaways? Anybody who can explain what is digital twin? I know it's very difficult, it's just a simple YouTube video for a short few minutes, but that's the power of what can be done, right? And this video is very old. It is almost 5+ years, 6 years old. So there's a lot more that has happened since then, and this was just something I could quickly hand over to the colleagues here and ask them to, I think. So very good afternoon to all of you. So hope you all had a good lunch. Okay, I can make out from your voices, so your lunch was probably good, yeah? So, okay, so today's rapidly changing landscape, right? A rapidly evolving technology landscape, this fusion of intelligent computing and knowledge extraction, that is what we call as IC and KE, right? Is transforming how we interact with data and with information, right? So they say data is the new oil, right? So this is an old thing, but there's a lot more that has happened since then, right? So this interaction basically enables data-driven decision making, as he pointed out in the morning in the other lecture, Professor Iyengar. So the interaction basically enables the interaction between intelligent computing and knowledge extraction. It enables data-driven decisions that help in solving complex problems. And today, these solutions involve advanced computational methods using AI, ML, neural network, quantum computing across industries and locations, right? So that is the purpose of all the papers that you actually submitted, and some of you got selected, and some of you are also going about through the evaluation process, right? So the focus is basically on adaptive self-learning systems that kind of mimic human intelligence, right? You had a good introduction of that in the morning, right? So this is made possible with very well-defined process of retrieving structured, actionable insights from unstructured or semi-structured data sources such as text, images, videos, using AI techniques like data mining, NLP, that is natural language processing, ontology, using beam and ontology, which is one of your subjects today, computer vision, and also semantic analysis, right? So coincidentally, all of these topics were actually covered also this morning in the earlier session as such. So the intersection of AI, machine learning, data analytics, and big data technologies is very critical to transform raw information into actionable knowledge. And this offers the opportunity to leverage the interrelationship between humanity and technology, right? So whatever we create for a better life, for a better humanity, for a better human race. So this offers basically the opportunity to leverage the interrelationship between humanity and technology, right? So in this context, today I will try to actually highlight some 2 key areas with few case examples that you might have also heard in other forums, right? So in 2021, an agricultural equipment company, now I don't want to specifically name the company, an agricultural equipment company revolutionized precision agriculture, right, using intelligent computing for addressing 2 problem areas. One is food security, the other is resource scarcity. The resource could be water, it could be power, it could be energy, whatever, right? So this solution typically leverages machine learning, computer vision, which we saw this morning, and edge computing, and employs both convolutional neural networks, which is CNNs as we refer to them as, to analyze over 2,000 images per second, right? So entire farmland, you're actually analyzing 2,000 images per second, identifying weeds with 95% accuracy. So wherever there are weeds which are grown in between the farms, you're identifying them with this technology back in 2021, that is 4 years back, right? With 95% accuracy for targeted herbicide applications, right? So you're doing targeted spraying or dispersing of herbicide applications. So it uses transfer learning and knowledge extraction from its own global fleet data. So this agricultural company has a lot of data across the globe. So it uses that fleet data to optimize performances across these diverse conditions, right? So for somebody who's a local farmer, right? Let's say this local farmer who is being serviced by that company, they were facing rising costs and water scarcity and other issues. So they adopted the system a year later in 2022, and they increased their corn yields by 20%, which is huge, right? And then they saved roughly around $15,000 annually on herbicides and reduce water usage by almost 30%. Water is a very critical resource. If you're a farmer, you'll know the difference, right? Some of you may be coming from farming background or farming families. You will know the difference of the significance of this. So it reduced the water usage by almost 30%. So by 2024, this company made this in 2021, right? So by 2024, over 10,000 farms using the solution saved 1.2 billion liters of herbicide and 500 million liters of water, which is huge, right? It's showcasing sustainable agriculture. Now, this demonstrates how intelligent computing and knowledge extraction solves real-world challenges, inspiring AI-driven projects like this crop monitoring, for instance, right? So in another example, in 2022, a certain fitness company means a wearable company, it integrated AI-driven heart arrhythmia, right? Heart rhythms, basically. So heart arrhythmia detection into its wearables, right? And one of their early customers who didn't know that feature existed in their wearable, right? Somebody was wearing a watch, for example. One of their early customers in 2023 reported that its ECG feature, yeah. No problem. So in 2022, this fitness company integrated AI-driven heart arrhythmia detection into its wearables. And this person who didn't know that feature existed, one of their early customers in 2023, reported that this ECG feature actually detected atrial fibrillation. You must have heard of atrial fibrillation, right? If you have done some of these projects in your papers, some of your papers may have that. It's called AFib or atrial fibrillation. And it actually alerted her. It's basically a condition where the heart rhythm is not stable, it's unstable, it is at a different pace, right? So it alerted her to a condition that increased the risk of stroke, right, by over 5 times, right? So there's a risk condition when you have atrial fibrillation. So this basically alerted her to a condition that increased the risk of stroke by over 5 times. So the system's CNN or this convolutional neural networks system analyzed this heart rate data with 98% accuracy. That's a huge accuracy, right? Some of you might have done AI/ML algorithms and you've seen that how much it takes to actually on what kind of data you have to reach that kind of accuracy. So 98% accuracy, processing 30-second ECG readings in milliseconds on a low power, approximately around 50 milliwatt power chip, basically using edge computing. We talked about edge computing in this video as well, right? So using edge computing, and it cut energy usage by almost 70% compared to having that data in a cloud system. So the chip is actually in the wearable, and it's actually reporting that you're going to have a health condition which will possibly lead to a stroke because of your arrhythmia or atrial fibrillation condition, right? So this knowledge extraction basically classifies the device basically classifies this rhythms and it also adapts this health models to individual users. So it can be customized to your requirement. You might be a different person with a different body mass index or a different weight or height, etc., and so on. So it can be customized to individual users via transfer learning, right? You must have heard about transfer learning in your AI/ML subjects or in your classes, right? While data is collected anonymously from millions of users and it refines this accuracy. So by 2024, the technology actually helped over 500,000 users to detect atrial fibrillation. And it showcased scalable, energy-efficient healthcare solutions. So these were some of the early starters in the healthcare business. And people who did not know, today it's common, all of you may be having smartwatches, almost all of you here, or you must have at least seen them, and you must have used them for detecting your daily activities, number of steps and all that. But I'm talking about like several years back, right? So in India, 77 million people typically live with diabetes, right? That's data that has come from 2023 report, right? So in India, there are 77 million people with diabetes as per a 2023 report, and diabetic retinopathy, right? I saw some projects in another college, I'm not sure about the papers here, but diabetic retinopathy, it threatens blindness. So people who have diabetes can actually, it also can affect the eye and the optic nerve, right? So especially in the rural areas with scarcity of specialists, there are no eye doctors in many of our villages, right? So if a village person has to come to the city, is to spend the whole day, come and meet the eye doctor, ophthalmologist, and then get her diagnosis, right? So what happened is a certain eye care company, again I won't name the company, it partnered with Google Health in 2019 and deployed an AI-based diabetic retinopathy screening tool using intelligent computing and knowledge extraction, which is your topic. In 2022, a 55-year-old farmer in Tamil Nadu, he received, one of the early people who received an early DR diagnosis, which is the diabetic retinopathy diagnosis, by a quick retinal scan at the company's vision center, right? And it saved his eyesight for just an affordable 500 rupees. Right? Somebody who would have lost their eyesight, with the help of AI and with the help of this intelligent computing and knowledge extraction, was able to save their eyesight for an affordable $6, roughly 500 rupee treatment. So that's the power of what you can create as engineers, as individuals, right? So by 2024, the same company screened almost 1 million patients annually, boosting rural access by 70%. So cities and, villages which are not covered, were covered like 70%, and it's slashed the diagnostic costs by 90%, which means that it made more affordable for people, right? Showcasing a scalable and sustainable healthcare innovation, right? So that was one of the unique healthcare innovations, which is also something which is very critical in terms of our vision and so on, right? So security also plays a very important and pivotal role in all these solutions, in these applications, these products, and these services, right? So security is very important. That's what makes cybersecurity sector a very major growth segment and globally contributes to a range of careers in the cybersecurity space. So if any of you here are interested in cybersecurity, put your hands up. Be bold. Anybody who wants a career in cybersecurity or in security, you can put your hands up. I want you to stand up rather, if you can. Right? So you need to be ambitious. Don't feel shy. Okay? You can stand up if you have the slightest inclination if you want to do something on this. Shall I count to 3? 1, 2, 3. Okay, you want to remain shy. Okay, fine. So cybersecurity is a major growth segment where you can actually be right from an analyst to all the way to a CISO, right? So you can actually analyze threat, be an ethical hacker, and those sort of things, right? So as you may be aware, there's this World Economic Forum. You must have heard of World Economic Forum, right? So the World Economic Forum brought out a report which is basically on the future of jobs for 2030, right? The future of jobs in 2030. And they report, this particular report highlights this AI and big data as the core essential career skills combined with creative, analytical, and system thinking skills. So you either, it's like you're part of it or you're not part of it, right? So if you're either part of the AI growth map and the AI trajectory, or you left at the left side of the bell curve, right? So typically, AI and big data are the core essential career skills combined with creative, analytic, and system thinking skills, right? So you don't have any of this, go back home, think again, right? Do I need to look at some of this from a different perspective? Take a step back, analyze what you've done all these few years and studied, and what is it that you want to focus on, right? So somebody came and said something in our annual function and went away, right? So I might listen for 5 minutes, and then or half an hour, depending on my attention span, and that's about it, right? So I want you to seriously go home and analyze yourself, right? So engineers like you are very pivotal to India's nation building, driving significant advancements in key sectors such as telecom, fintech, software, automobiles, defense, aerospace, among others, right? Could be other areas also. So today, India's economic story highlights our country's transition into a modern economy, which is very poised for yet another huge leap, right? Our economy is basically poised for a huge leap, given that the contribution of industry and services together account for over 80% of India's gross value added, or GVA, right, at current prices. What is GVA? Anybody in the audience heard of this word? Gross value added. I'll repeat. Today, India's economic story highlights our country's transition into a modern economy poised for yet another huge leap, given that the contribution of industry and services sectors together account for over 80% of India's gross value added, or GVA, at current prices, right? So figure it out. come back and tell me what is GV, right? So increased investment in technology and industrial production has typically fueled remarkable growth and established India as a global hub for product engineering and for technology services, right? So we were only known as a BPO company a few years back, but today there are a lot of entrepreneurs, there are a lot of startups, there are a lot of focused technology areas, deep tech happening in India. So you need to be part of that whole ecosystem. You need to aspire to be part of that whole ecosystem, right? And you can be entrepreneurs, or you could be part of a larger movement as part of a company, right? So typically, India as a global hub for product engineering and technology services is making it really a giant leap in terms of where we want to go. So India's ability to deliver reduced time to market, right? We can quickly deliver a product within 3 months or 6 months, right? We deliver a product, reduced time to market for digital automation, cost efficiencies. These have been crucial in boosting some of these industries to achieve that 80% GVA, right? So today, while the AI ecosystem is evolving at an unprecedented pace, it offers significant opportunities and tremendous scope to our engineers for reimagining LLMs, right? Especially from an Indian perspective, right? What do you mean by LLMs from an Indian perspective? Anybody can answer that from me? Correct. Where is it coming from today? Correct, correct. But who creates the LLM? Who owns that LLM? Okay, it's a separate topic. We are also online. So today, while AI ecosystem is evolving at an unprecedented pace, offering significant opportunities and tremendous scope to our engineers for reimagining LLMs, especially from an Indian perspective, not just from the point of view of incremental improvements, right, but also at the basic architecture level. We have a huge wealth of information as a culture, as an Indian civilization, right? So the way we look at things are not in the form of probabilistic theory. Everything that you see in the AI world is in the form of probability theory, right? Yes or no? Right? So when you look at nature, can you put a probability aspect to it? When you look at some of our ancient scripts and some of our ancient content that we have, I don't want to go in that direction, it's a separate topic altogether, but do you think you can actually create something which is different, disruptive, and completely different view of what we call as AI and what we call as LLMs, right? Do we need Bharati LLMs or Bharat Gen? Whatever, right? So you can go back and ask yourself these questions, right? So let me share also an overview about Nokia's journey in this space, right? Having shared what India has been doing. So Nokia is a 160-year-old company. How many of you knew that here? Nokia started 160 years back. It is based out of Finland, and it started as a paper mill, pulp and paper company, which moved into rubber tires and televisions and so on, right? And today, it's one of the global technology leaders, especially in the wireless communication space. Our innovation journey has witnessed several milestones across 100 years of Bell Labs innovations. So Nokia Bell Labs is basically the innovation arm of Nokia, basically. How many of you have heard of Bell Labs? Yeah? So the key innovations from Bell Labs includes the transistors that you use. Every one of you has used a transistor in your lab or in your projects or somewhere else, right? That transistor was introduced or created or discovered in Nokia Bell Labs. Who invented the transistor? 3 people. Give you a clue. Can anybody give me one of the names? Who invented the transistor? One name. There are 3 people who invented the transistor from Nokia Bell Labs. You use it every day in your every aspect of your life, right? A transistor used to use vacuum tubes before that, right? So, okay, come back after the session, but don't Google, okay? So, key innovations from Bell Labs include the transistors that actually revolutionize electronics, and then Claude Shannon's information theory, right? All of you would have studied about Shannon theorem and Shannon limit, entropy of information, right? So Claude Shannon used to work in Bell Labs, Nokia Bell Labs, right? So Claude Shannon's information theory, which is the foundation or foundational for modern communication systems. And also, how many of you have heard of this paper called A Mathematical Theory of Communication? That was the fundamental paper that changed the world of communication and how we are able to talk about 1G, 2G, 3G, and 5G, etc., which we talked about. It was written by Shannon along with a couple of other colleagues in 1948. It's called A Mathematical Theory of Communication. If you can go back home and read that today or in the weekend, it would be great. He also wrote another paper, Communications in the Presence of Noise. And that was basically a path-breaking information in terms of how you could actually communicate and also have mathematical representations in basically looking at noise. And that noise plays a very significant role in AI today in the form of privacy and differential privacy and so on and so forth, right? So Claude Shannon's information theory is foundational for modern communication systems, and the Bell solar battery, the solar battery was invented by us, the first efficient solar cell for converting sunlight into electricity, right? So these are the contributions from Nokia to the world, right? The transistor, the information theory, right? The solar cells. Advances like laser fiber optics, satellite communications, charge-coupled devices, CCDs, right? We got a Nobel Prize for that. CCDs and cellular communications transformed our entire industries, transformed industries from global broadcasting industries all the way to digital imaging industries for robotics, defense, and medical diagnostics. The software systems like Unix, C, and C++ were founded by Bell Labs. Koenig and Ritchie used to work in Bell Labs in Murray Hill in the US, right? Likewise, Bjorn Strostrup, right? So Unix, C, C++ is the contribution of Nokia to all of us here today who are using that in our everyday lives, right? So this software systems like Unix, C, and C++ founded by Bell Labs powered the internet and large-scale data processing. Nokia Bell Labs has also contributed to neural networks. We talked about them in the morning, right? Nokia Bell Labs has also contributed to neural networks, super resolution microscopy. In addition, the Nokia Bell Labs are pioneers in advanced AI, biological research, and wireless communication. We are the only company today who have made wireless communication possible on the moon. We work with NASA to make communication possible in the moon, right? So Nokia Bell Labs has earned an impressive array of accolades, including 10 Nobel Prizes for breakthroughs like the invention of the charge-coupled devices, the discovery of cosmic microwave background radiation, which was basically substantiating the Big Bang theory, basically. So the discovery of the cosmic microwave background radiation and the Nobel for quantum dot synthesis as late as in 2023. So in 2023, we won the Nobel Prize for something called quantum dot synthesis. And these and other prestigious awards, including 5 Turing Awards. So this morning, we were talking about Turing Awards, right? Professor Iyengar was talking about the Turing Award. So these and other prestigious awards highlight Nokia and Bell Labs' profound impact on global innovation across engineering, computing, and communications. Nokia has identified 6 pillars of responsible AI. Right? We have identified 6 pillars of responsible AI, and these include transparency, sustainability, reliability, which includes safety and security, privacy, accountability, and fairness. Right? So Nokia is facilitating many automated and intelligent applications that build on mission-critical edge platforms, reliable wireless connectivity, unified data lakes, and secure and customized AI algorithms across verticals. And these interventions provide actionable insights, right? We talked about actionable insights in the video just a few minutes back. The video was meant basically to get you to understand what I mean by actionable insight. And this morning when I spoke about somebody able to use a tablet and also manage their contextual data and their situational data is basically the actionable insights which we get and from these critical industry edge platforms which provide this reliable wireless connectivity, unified data lakes, and customized AI algorithms across verticals. So when these interventions actually provide these actionable insights and situational awareness for improved real-time decisions and efficient workflows. So the entire workflow is automated, right? So in conclusion, AI cannot be in a black box, right? We also saw that in another session this morning, right? Coincidentally, I also have it. So in conclusion, AI cannot be a black box. While these algorithms have to be innately explainable, right? You need to be able to innately explain these algorithms, like in the case of decision trees, right? You might have come across decision trees in your models, right? So use of causality and what-if analysis, right? Use of causality and what-if analysis, which plays a key role in avoiding hallucinations, right? What is hallucination? Can an AI hallucinate? Can AI system or model hallucinate? Yeah. So these use of causality and what-if analysis plays a key role in avoiding hallucinations and improving the quality of AI-based predictions and output, right? So the data that teaches our AI tools and models must be ethical, right? The data that teaches our AI tools and the modeling that we do for inferencing the data, right? Whether it's testing data or training data, right? So the data that teaches our AI models and the AI tools and models must be ethical, it must be accurate, it must be secure, and it should be accessible, right? In order to create new and differentiated services that improve our productivity and life in general, right? Human life. It should also reduce operating costs while enhancing our user experience, right? So that's the purpose of this whole thing, right? Why do we create AI? AI is not the solution for every problem in life. There are several cases where you can use a smart solution. You don't need an AI solution. AI is not the answer to everything, but AI is useful when you have a lot of legacy data, you want to train that data, you want to basically process that data, and you can infer something from the data and take some actionable insight out of it, right? So basically it helps to also reduce costs, enhance user experience, and so on. So ensuring the accuracy of the extracted knowledge, addressing biases in the data, we talked about bias, right? People can be biased in the way they configure these things. Ensuring the accuracy of extracted knowledge, addressing biases in the data, and maintaining privacy are extremely critical when you are working on AI. Because you are the engineers who are going to go out tomorrow and work in companies, and unless you have these things in the back of your head, you're not going to be basically a good engineer, right? So ensuring the accuracy of extracted knowledge, addressing the biases in the data, and maintaining the privacy are extremely critical, right? It is also important to highlight that energy efficient algorithm design is key for training and inferencing data. AI systems consume a lot of energy, right? You probably know that, but you don't know how much, right? So it's also important to highlight that energy efficient algorithm design is key for training and inferencing data. For instance, using simpler algorithms need lesser processing, right? You may have heard of a concept called knowledge distillation, right? How many of you heard of knowledge distillation? So this knowledge distillation methods where these larger modules are used to train smaller ones, right? So you saw a brain with a lot of nerves going out in one of the pictures. That must have stuck in your mind, right, in the morning. Now that large network of those convolutional neural networks which are there, if it can be basically used to basically condense it into a smaller network, you're basically able to do knowledge distillation in a certain way, where large models are used to train smaller ones, and these then contribute to better energy efficiencies. Also hosting your data systems in cooler environments or in very cold environments like in the Arctic or in Scandinavian countries and so on, right? So data centers generate a lot of heat, and everything that you do, if you go towards quantum computing, it is even more going to be more complex. So today the world is struggling with how to manage the demand that you people are using. Every single one of you are probably using ChatGPT or Grok or Perplexity or whatever is the available AI options, right? But every command and token that you give is actually causing a lot of energy usage at the back end. So you need to have a balance in terms of what you're trying to solve with AI and how much energy it is consuming. And if you don't have that balance, you're going to be not having a sustainable solution or innovation. Your innovations, your creation should be always sustainable in nature, right? So it's important to create that balance, right? So you need to have better energy efficiency. So improved experiences in healthcare, transportation, smart cities, secure networks, simultaneously balance high computational demands with sustainable energy solutions, right? So I think you're waiting for this last line. So let me conclude this message. As today's engineers, you have the opportunity to integrate contemporary cutting-edge technology with ethical innovation. I'll repeat, you as today's engineers have the opportunity to integrate contemporary, cutting-edge technology with ethical innovation, you can unlock new potential and you can address complex challenges only if you want to, right? If you can doze off, then you may probably not want to, right? So you can unlock new potential and address complex challenges. So is it Netflix or is it innovation? You take a call, right? You want to look at your phone and be distracted, or you want to do something constructive? How much time do you want to spend on your phone in your WhatsApp or Instagram or whatever it is, right? And how much time do you want to spend trying to create something for humanity, right? Addressing the food security issues of the world. Can you do something for an agriculture, for a farmer in the village, right? Those sort of things, right? So you can be the change makers contributing to a sustainable future, right? So you can be the change makers who can contribute to a sustainable future with your ethical innovation and your insights that you gather looking around you, right? So don't plagiarize in your papers. Look at original content, original research. Ensure that you're actually doing something. Make use of the tools, but make sure that it is originality in terms of what you create as well, right? So with that, I would like to end my speech. Thank you so much for listening to me, and I hope you go back with something from this session. Any questions? Yes, already, yeah. So for example, in the networks, you look at the network, you want to know which are the networks which are actually operational. Countries like Australia don't have the networks to be operational everywhere, right? There are a lot of sparse populated areas. You can switch off the radio base stations when they are not in use. You can monitor the amount of traffic without having to violate the data privacy as such, right? So agentic AI is already being used in several of these applications. Although it is a new topic, maybe people might be getting familiar with it. We do have those in-house, and we don't use the external ones. It's confined to within the company as well. So we have several toolkits, and infrastructure for that. And if you want to test your 6G applications, 6G use cases, we have a 6G lab in Nokia, which is in collaboration with IISc. We have set up a 6G lab. Last year, I think in 2023, we launched it. We made it public, basically. So, but not 5G. 5G, you have your own labs. Many of the colleges have their own labs. But if you want to do some 6G use cases, which is basically human-centric, sensor-driven, right, AI-driven, etc., we are happy to help you out and support. Anything else? Any questions? Either everything was very clear or nothing was clear. Okay, so thank you, and over to Anuj. Thank you.
Good afternoon, everyone. It's my honor to extend a heartfelt vote of thanks to our speaker, Mr. Sunil Jain, for delivering such an insightful, thought-provoking session today. Your talk was not only for informative, but also very inspiring and engaging, sir.
Thank you.
On behalf of the entire team and participants, I sincerely thank you for coming here, taking time out of this and be with us. And we're looking forward for more such interactions in the future. Thank you so much. We welcome for the next speaker, Mr. Anuj Gupta.
Thank you.
Thank you.
I'll log in. Do you have the slide changer and mic?
You want the mic?
Huh.
Is it working? We keep it in the pocket or in the
You
belt
can
anyway.
put a clip.
Check once.
Hello.
Now inside.
Hello, can you guys hear me? Right. So right now we'll be talking about the word that you've heard 1,000 times today, AI, and we'll be diving deeper into the fundamentals of AI. Which one? Sorry? Organized intelligence, yes. So that is just a kind of an offshoot of AI, I would say. So right now I want to talk about the basics of AI, how AI actually works. AGI is a concept, it is not there yet. Alright? Okay. So as part of Qualcomm, I'll be talking about cloud AI models and what are Qualcomm's solutions towards it. Does this work? Okay. Okay, so first let's try to see what are the trends in the model, how the models have evolved. So from 2000 onwards, up until now, the sizes of models have just ballooned exponentially. The real pivotal moment for AI came in somewhere around 2012 with AlexNet, a model that really won a lot of laurels because that was the first one where people started thinking that AI can actually be put to real use. Prior to that, like AI and ML has been there for more than 50, 60 years. But around 2000s is where its practical applicability started coming up. And now we are at a point where the sizes of models are not even in millions. Meta just announced that they are going to release a model called Behemoth, which will be 2 trillion parameters. Now, just to put that in perspective, one parameter, if you run in FP16, floating 16, each parameter will take 2 bytes, right? 16 bits needs 2 bytes. 1 billion would need 2 GB. 1 trillion, just calculate yourself. How much memory would that model need just to be loaded in the memory? That is the amount of scale that we're talking about. And that is why clouds are becoming so much popular. You all might have heard about Moore's law, which has driven the evolution of transistors, right? In similar terms, AI is driven by its guiding principles called scaling laws, AI scaling laws. Now, what early scaling laws defined was that if you have a very large data set, you train a larger model and you put more and more compute, your resultant model is bound to be better than the previous one. So there was a massive gold rush. If you see 3 years back, every single week you would have a new model which is better than the previous one, bigger than the previous one, primarily driven by the scaling laws. And what the scaling laws said that for each parameter that you are training in your model, you need around 3 tokens to train it with. So for example, if you want to train a 1 billion parameter model, you start with a data set which is around 3 trillion tokens. Chinchilla from Google DeepMind introduced a new law that 3:1 is not enough. We need at least 20:1. Okay, so there were a series of models with this kind of ratio. Then when Llama models came about, they shattered the entire theory. They started off with 200:1. And the first Llama model which came about, which was 7 billion parameter model, it was trained on 15 trillion tokens. So the scaling laws itself are evolving in AI along with the technology itself. And what scaling laws established that there is a power law relation between the compute data set and the parameters, which is why there was the massive explosion of sizes. Now just to again visualize, in 2018 we were talking about models which was some 10 million parameters because in 2017 was the famous paper which came out from Vaswani, Attention is All You Need. That really formed the basis of transformers, and from 2018, a 10 million parameter model itself was considered to be out of the world, and now we are talking about something which is 2 trillion. It's really tough to even create graphs when the sizes are changing every week. And then on the left side, you see the sizes of the model, and on the right is the context length. Are you guys aware of what is a context length in a model? Okay. Context length is the amount of words or tokens the model can store and then predict based on that. So what it really means is, if let's say you see a context length of 50K, that means the model can generate at most 50K tokens or words, nothing more than that. So the context length itself is increasing, and now the latest models from from Meta, it's called Llama 4 Maverick. It has a context length of 10 million tokens. These are just outrageous numbers just to even think about it. Now, generative AI broadly can be categorized into 2 categories. One is the evolution on the modalities and the use cases, and other is the capabilities and KPIs. On modality and use cases, you can see that now there are reasoning models, there are multimodal models, there are video generation models, image generation, code generation, you just name it. On the capabilities, you see higher resolution, more personalization, increase in model sizes, increase in context length. So the capabilities are just continuing to increase. Now, what really is that language model? We all talk about LLM, right? Does anyone understand what really happens inside it? So let's just take a deep dive into it. What is the definition of a language model? To put it very simply, given a text which we call as a prompt, a language model will predict one subsequent token. So when you use ChatGPT and you say, can you write an essay on something, and it dumps out 1,000 words, what is happening behind the scenes is the model has run inference 1,000 times. For generating one word, the model runs the entire model once. So the structure of an LLM, as an input, it takes a sequence of tokens, which is the prompt that you passed to the model, and the output is a probability distribution. And by probability distribution, I mean that the model has a fixed set of vocabulary. Let's say a model understands 50,000 words. So the output is a probability distribution which tells that this next word is probably XYZ letter. And that probability, so what application has to do, it has to select the word with the highest probability. That is how LLMs print their output. LLMs are autoregressive. What is autoregressive? Autoregressive means that any word predicted by an LLM depends on the previous word that it predicted. So LLM will not predict any word in isolation. So let's say you gave a prompt of 100 words. In the first iteration, it predicted 101st word. Then that 101st word is used to predict the 102nd word, so on and so forth. That is what is the meaning of autoregressive. LLMs can generate multiple completions. It means that in one shot, it can generate 2 or 3 words, but then the application has to select one out of those. Now, with this definition of LLMs in picture, what are the architectural implications to deploy them? For performance, like I mentioned, for generating generating a sequence requires several invocations of models. For example, you need n independent invocations of the model to generate n different tokens. For the compiler, input is a variable shape because the user might send a prompt of 10 words, 15 words, 20 words. And for compilers, if you guys have ever worked on compilers, the most optimal compilers like static shapes because the compilers like to put a complete schedule of operations ahead of time. So having a variability to input is a massive challenge for designing any compiler system. And then, like for autoregressive nature, each word depends on its previous words. So naturally there's a loop, like a for loop or a while loop. So then there's a decision, where do you put that loop? Is that loop running on the device? Is it running on the CPU? So all these are architectural implications which just come out of the definition of LLM. Now it's going to get heavier. So there are two terms you might hear, a prefill and a decode. What is prefill? When you use any AI app like ChatGPT or Claude or anything, you pass a prompt. That prompt, when it's going to the model, that entire sequence of tokens is called a prefill stage. Prefill stage is the stage where LLM takes all your prompts in one shot and generates that p plus 1th token. That is what is prefill stage. And after that, it is one word at a time. That is called a decode stage. So just to repeat, prefill stage is the stage where the LLM takes your complete prompt as an input to generate that one next word. And after that, the entire generation, entire completion that the LLM has done is called the decode stage. So what really happens in this prefill stage? You see this arrow, P tokens. P tokens was the input, and the output of LLM was logits, which is nothing but probability for the next one token. And you see this something written as KV dollar. Anyone knows what that is? KV dollar is actually KV cache, which in LLM parlance is the probability of all the words, of all the hidden states that LLM had. So for example, ChatGPT, or let's take an example of a Llama. Llama model, which is, let's say, 70 billion parameters. It has 80 layers, 80 transformer layers. So this KV cache is the intermediate output of each of those layers. Now, why is that important? Because the models are autoregressive. When I say the models are autoregressive, only just the fact that the model generated a word called but will not be enough for the model to generate the next word. The model needs the entire intermediate outputs of the previous inference to generate the next inference, which is what is KV cache. So in the decode stage, if you see, this word which was predicted is now the input to the LLM along with the KV cache. And now the model has generated the next word and the KV cache for the p plus 1th word. Likewise, you pass this token again and the KV cache for p plus 1th word, and it goes to p plus 2. So this is how LLMs typically generate inference. Now, if you see here, in prefill, what happened? Your entire prompt went in one shot to the model, and in decode, you are passing one word at a time. So when you're passing the entire prompt to the model, let's say your prompt was 100 tokens worth. The model is going to consume all those 100 tokens in one shot. It will read the weights of the model once. So where are the weights of the model? They are sitting on the accelerator somewhere on the GPU in the cloud. So when you're doing that inference, the way any computational system works, your weights are in the DDR, but when you have to do any mathematical computation, you pull the inputs into the registers and then you do the computation. So like that, when the weights of the model are in DDR, for doing any inference, the weights will have to be read from DDR onto the L1 cache or L2 cache, and then the operations will be done. So in the prefill stage, for all those entire P tokens, the weights are read once because it's just one inference. But in decode stage, for each word, you have to read the entire set of weights once more. So just imagine a ChatGPT, which is around 175 billion, or a Grok, which is 300 billion parameter model, and you ask that model, what is the weather of Bangalore? It just says hot. Was it really worth it? Of reading 600 GBs worth of data just to predict that word hot? This is why the decode stage is heavily memory bound. What I mean by that is, let's say your GPU or any accelerator has a DDR bandwidth of 100 Gbps. and your weights are 10 GB. No matter what you do, you cannot clock more than 10 inferences per second. Because for each inference, you have to read the weights once. So if your DDR link is 100 Gbps and your weights are 10 GB, no matter what kind of sophisticated architecture you can bring, you will never get more than 10 inferences per second. That is why most of the innovation right now is happening on how to reduce the footprint of the weights, how to quantize them into lower and lower bit width. Now, very similar to the original workflow, for Qualcomm, what we have done is we have optimized it heavily such that we don't DMA all these extra things onto the host and then send it back to the accelerator. We retain them on the device. We have our own mappers and routing tables to make LLM understand what to use and when. We have several patents around it. And what really happens here is the two stages, the prefill and decode, we merge them into one with some automated systems. We have logic around telling the LLM what to do when. No. Client server is for LLM serving, something like OpenAI APIs. But what I'm talking about is how the LLM at its core is working. When you have a client and server model, the client is the user. Server is where the model is working. But how the model is working at server is what I'm explaining. Now, LLMs, as much as they are in rage right now, are also very soon going to be taken by next thing in the AI. And what is that next thing? LLMs still cannot plan. They cannot reason. The output of LLM is what it has learnt over its training. That is why if you ask any LLM, what is 5 plus 2? It will just print 8 without even knowing that 8 is right or not, because it's just dumping the output. It doesn't wait for thinking. So LLMs do not think. But then for any practical application of AI, you want the AI to be logical. You want the AI to be sensible. And that is where the next phase of AI is coming in, which is called LRM, large reasoning models. Did you guys hear about DeepSeek? What happened with DeepSeek? They created this new model called DeepSeek R1, which is a reasoning model. And so OpenAI also has the reasoning models, but they are very expensive. They have not really opened them out. And what DeepSeek did is they created a reasoning model with a fraction of cost. And that is why all the buzz. So LRMs are the next wave. So what is coming next? Like pre-training as we know it, like we discussed in scaling laws, for compute to grow, we are continuously evolving to a better hardware. There are better algorithms. There are larger and larger clusters of data center. But the data is not growing. All these models have already used up entire internet. All the models are already getting trained on every single information which is available on the internet. Now, if you have to create a differentiation in a new model, how do you get new data? Data is not expanding. So Ilya Sutskever, the pioneers of AI, this year made a very bold statement that AI data is the fossil fuel of AI. It's almost dead. We don't have data at all. So now what do? How do you still continue to make your models better? So this green statement is the answer. Instead of training larger and larger models, can we run smaller model for a longer duration to make it smarter? And the answer is yes. You don't really need those fancy 1 trillion parameter models to outsmart any previous LLM. You just create a small model, but make it think. And that concept is called chain of thought. You break your input into a series of small problems, tether them together, and that small problem can be handled by a small model also. And now, when you're talking about creating that small model and running for a longer period of time, what it really means is optimized inference is now important for model creators also. Till now, the model creators were happy by training the model, and inference was a consumer's game. If I have to use the model, only then I'm using inference. But now for model creators also, inference is important because the models are now going to think on the fly. Just look at that blue thing at the top. Solve this riddle. Can anyone even make sense out of it? But then, if you pass that to a reasoning model, the reasoning model is able to understand what it is. The reasoning model says that, okay, this looks like a base 64 encoded thing, and it does whatever it has to do and comes up with an answer. And the answer is Cardi B, Charlize Theron, and Chris Hemsworth. Answer to that, those gibberish numbers. That is the power of reasoning models. It was able to think through, it was able to understand what it is and what are the next steps. So this is really impressive, and this is the next wave of AI. And that is what is called chain of thought reasoning. So enough said about LLMs. Now, let me switch gears to what is Qualcomm doing for cloud AI. It is also like, so LRM has a concept of thinking tokens. So like when you use a chat GPT, all the words that the model has generated are printed on the console. But in case of LRMs, everything that the model is generating is not getting printed out. It is blabbering in its mind, like what humans do. Let's say I ask you, what is the square root of 289? You start thinking in your mind. That is what LRM is doing. No, LRM is not having data. LRM is able to break that problem down, and it is thinking. But then in due course of thinking, it is running inference, but it is not printing the output. That is called thinking token. Like what you do. If you calculate square root of 289, you will not start writing right away. You start thinking. That is what LRM is doing. It is breaking the problem into smaller parts, then trying to piece together information, and then give the final output. So in AI, now we know of AI from October 2020, most of us, when the chat GPT moment came. But then Qualcomm has had over 15 years of AI investment. Now, most of the phones have a Snapdragon chip, which has an NPU. We call it a neural processing unit, which is running most of the workloads by AI without you even knowing it. Now, let's say you take a photo. Photos are always better than how you look. How is it that happening? Because the camera, the chip there has a lot of sophisticated algorithms. It is able to do a scene prediction and all fancy stuff. So there's a lot of AI which is already there in Qualcomm devices already. Very recently, Meta released glasses with 2 cameras. They have Qualcomm smart glass chip. So there's a lot of history about Qualcomm's AI investment, more than 15 years. And this product you see here, Cloud AI 100, is Qualcomm's entry into data center. So we all associate AI with GPUs. So now, like Sunil mentioned, AI is very costly. Now each inference, like, did you see a post from Sam Altman 2 months back? He said, don't write please and thank you when you write a prompt to the model, because each word has to go through the inference. And they are using hundreds of billions of parameter model. So each word is costing them dollars. So running AI is very, very expensive. So what Qualcomm is doing, as what we do the best, highly efficient computing. So we have created a new hardware accelerator for cloud AI, which is very, very power efficient. So just to give you a perspective, a single GPU takes around 700 watts per inference. Cloud AI 100 takes 150 watts. So there's a massive, massive power optimizations that we have baked in. And now we are entering a data center space with our server scale products. It's already in public clouds, and yeah, several generations of it are in the works. This is our software stack. Now for GPUs, most of the software comes from open source. For Qualcomm, we are building everything in-house. So we have 2 types of software SDKs. We call them a platform SDK and an application SDK. Most of the models get coded up in PyTorch today. We support PyTorch, TensorFlow, ONX, Keras, everything. And we have a completely inbuilt compiler and software tools story, which can run pretty much all the models that you have right now. Even the latest like Llama 4, we support from this stack. Our cards that I showed are available in public cloud. You can log into that website, cloudai.cirruscale.com, with your Google ID. You can run the models for free using Cloud AI 100 from Qualcomm. You would see this kind of an interface. You can do chat, image generation, you can run agents, whatnot. And now, to sum it up, I'll leave you all with a small video. No, it's in several locations in the world. Yeah. No, so we are partnering with the vendors now, like if we are in AWS. Now, AWS has placed our cards in which all locations we don't know. We have our own proprietary SDK. So what we are doing, we are taking open source models, we are building tools and compilers to make those models optimized for our hardware. And as part of our stack, there are some pieces which we have open sourced, some are closed source. So there's a library called Efficient Transformers. You can look it up on the internet. That we have open source, using which you can run any of the models on Qualcomm SDK, provided you have a way to log on to the hardware. Oops, the video stopped somehow. No, there's no audio. Yep. From a Google ID. Just with the Google ID. Thank you. This is all I had. If you guys have any questions, please let me know. Thank you. Yeah.
Coincidentally happened to be the same conference when the Ilya mentioned it.
Okay. 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 Excellent.
You're talking about also looking at, like I said, breaking it down into smaller.
Yes. Yes. Yes.
There were some slide that I saw, some transformers and specific libraries. And it said that one more libraries and services are there. What is the difference between this?
So the library, transformer library, is an open source library, which I only open sourced actually. It's called Qualcomm Efficient Transformers. And the library, is, the services part means that we have inference as a service also. So right now what I showed, that link, if you log into that and you are running inferences, that is inference as a service. It's just that that service is coming for free for you right now. We are not selling you bare metal cards The service is deployed in the cloud and you're running. That's what that service is. Any other questions? All right, thank you. Thank you, everyone.
Once again, good afternoon. Grateful for your time and look forward to future interactions. Thank you once again, sir. Thank you so much. We have one more speaker online. We wait for some 2 or 3 minutes.